The last example I want to do like this before we move on to non-homogeneous equations, I want to talk about complex roots that are repeated. So something like, let's say you have d squared minus 4d plus 13 squared times y equals 0. Okay, so here we have a differential equation. It's a 4th degree differential equation because when you square a quadratic polynomial, you get a 4th degree polynomial. Anyways, so let's figure out what's going to happen here. And the first thing that we need to do is we need to figure out if we're going to have d squared minus 4d plus 13, that means that we really need to look at r squared minus 4r plus 13 quantity squared equals 0. So that's the equation that we're going to need to solve. And that's going to be 0 when, of course, the r squared minus 4r, when the base, not the exponent, but when the base is 0. And then that's going to happen. Let's see. This is r squared minus 4r plus 13. If the left side was r squared minus 4r plus 4, it would be a square. So if I want to leave 4 here, I need to subtract 9 from both sides. And therefore, this is going to be r minus 2 squared equals negative 9. And then when we take a square root, we're going to get r equals 2 plus or minus 3i. Now, this is a pair of complex solutions. This pair, each of the numbers in this pair, I should say, has multiplicity 2. So we need to be a little bit careful with what's going to happen here. And so it turns out what's going to happen is we're going to have 2 plus or minus 3i as our solution. So you're going to have e to the 2x times c1 cosine of 3x plus c2 sine of 3x plus an x e to the 2x times c4 cosine of 3x plus c5. Here I can squeeze this all into a line, so I will. Okay, plus c5, c4 and c5. What am I talking about? c3 and c4. Sine of 3x. Okay, and so that's what's going to happen there, is that you have not just one of these terms, e to the 2x times, in this case, c1 cosine 3x plus c2 sine 3x, but you have another one where it's x e to the 2x. And then possibly these are different constants, so we need to call them different values. Okay, but that's how repeated complex roots will work.